EC 111 Lecture 9, Set 3, Parameters. We already went through this a few times in the class where we showed construct with hash and a parameter name, or the parameter declaration, where we can declare a parameter. Here are just a couple more examples of that. The module that has a parameter is called the parameterized module. The parameters constants can be used to define port signal, local variable, and the width of the nets. So basically you could declare something and you could have a net size, or the number of, for example, some input is 4 bits, and then when you call that function you could make it more bits, or you could change other parameters in your design. In one module, we are not limited to by the number of parameters. We could define multiple parameters inside design. And, here is just an example of a half adder with parameter 1. In this half adder declaration, we have this hash sign is always used for parameter declaration, and then parameter in this half adder, 1-bit half adder, we use n equal 1, and then in n equal 1 the input are 1 bit and the output is also 1 bit, and we just assign the function. So the function is going to be similar, but then when we call this function at the top level, what we are going to do is we are going to change the value of that parameter. Here, notice that we use that dot notation that we just learned for connecting the ports. In the top module, we have the input and output specified, and then this input in 1 and in 2 are going to be passed to the adder, and as you see here, and the sum is going to be here. And now what happens is that the parameter n that we defined as 1 is going to be 4 in this instance as we pass the parameter through this function. And now what happens is that the sum is going to be summing up two 4-bit numbers, not a 1-bit number again. The important thing to know is that there are 2 types of parameters that we have. One is a global parameter, which is both of these are a runtime constant, but we could externally modify them. But local parameters can be internally modified as we go through the module inside the module. The global variables, or just parameters, can be defined to go at the top level. We could change them like what we have seen. And the syntax for both of them are similar. Here is another example where we have a parameter n1, and we go through the logic. Now in this other example, we define the parameter by these values, and you could also have local parameters here, as can be seen. So some of these are real data type. You could define parameter as integer type. There is basically, you could have logic assigned to that. You could have sign value. Whatever you assign to it, it's going to go with that. And here I'm just defining some logic type, and these can be all done in your parameters. So the parameters can be also overridden using the def parameter during module instantiation time. And it's actually, this def parameter is a little tricky. You could use def parameter even before you instantiate a module or after you instantiate a module. And something to remember for parameters is that parameters are actually just for the programming type. In reality, every time we have a variable or a parameter that is defining something in system some Verilog, we are not really just doing a program and running some variable through the program or through the memory. We are creating more hardware. So, during the you cannot have these parameters usually dangling after synthesis or when we have a simulation of that hardware, which is pretty much kind of similar to synthesis. So these parameters, they need to be having, during the runtime, they're considered constant. We synthesize them, we get a piece of hardware, and that's the one we use. The only advantage of them is making programming easier. And now the def parameter that I'm showing here in the top module is going to create a half adder instance. So here, let me just go quickly here. So we have a module half adder, and here we are having a module instantiation half adder instance, which is basically making an instance of the half adder with the input and output logic that we had earlier. And now here I'm defining, there was a parameter in my adder, and that parameter I can redefine here. And redefine here, I had a parameter width equal to 1, but here I'm just going to define the parameter half adder instance, or HA underscore instance, dot W equal to 4. And this dot W says that this parameter is going to redefine what was defined as a parameter in the submodule. And the important thing to remember that this def parameter can be declared before module instantiation or after the module instantiation. But of course, every time you do it and you call something, you need to make sure that when you change something and you call something, that value is set to first. So in this particular case, the half adder instance is going to use the dot W equal 4 when it's running, and then you could change it, or you could change N and do other things to it. In the next set, we will be talking about modularized design.